let's do function composition with graphs. Now, when we're talking a graph, once again, we're going to start on the inside. So we have this inside function f of 1. That's where we begin. That's step 1. So step 1, I want to find what f of 1 is. Now, hopefully, you remember from 1.1 that this is just another way to write an xy coordinate pair. There we go. Because this is x, comma, y. So, excuse me, we want to go to the f graph and find a point on the f graph that is 1, comma, something. We don't know what that is, but we want the x value in the coordinate pair to be 1. So hopefully you can see right here on the f graph that happens right there at 1, comma, something. This is the only point on the f graph that has an x value of 1 on it. So if I find that something, this is 1, comma, 2. So that is the answer to that part. 1, comma, 2. Now I'm going to use this answer. Let me fix this real quick. And I'm going to plug 2 in for all of f of 1. So essentially, I'm going to replace all of f of 1 with its answer, which is 2. So you can see right here, I took f of 1, replaced it with a 2, because that was the answer. And now this is the second part of the problem. I want to go to the G graph and find where the x value is 2. I want to find the coordinate point on the G graph that is 2, comma, something. So I come over here to the G graph. I want to find 2, comma, something. So let's see, where is 2, comma, something on the G graph? Right there. That one is 2, comma, something. That is the only point on the G graph where x is 2. So I look at finishing it out, it's actually 2, comma, 3. So that means I can put that answer there. 2, comma, 3 is the point. And that means 3 is my final answer. G of f of 1 equals 3. Let's do one more example together. Once again, we start on the inside, G of 3. That's what I want to find first. G of 3. So I go to the G graph and I want a point that is 3, comma, something. Here over to the G graph, right there. That point is 3, comma, something. And that something is actually a 0. That's that point, 3, comma, 0. So now I can come over here. That point was 3, comma, 0. And now I can move on to step 2, where I replace G of 3 with its answer of 0. So that's going to give me f of 0 is what I want to find next. So now I'm going to go to the f graph and find the coordinate point where x is 0. So where does that happen? Looks like right there. That is 0, comma, 4. That is the point on the f graph. So then I can put 4 here, and that is my final answer. So now I want you to pause the video and try out C as the last one in this type of problem. And then come back and see how you did. Let's see how you did. So we started with the inside, which is G of 3. We already found out G of 3 in the last problem. We know G of 3 is 0, 3, comma, 0. So now I plugged 0 in for the inside. So now I want to find G of 0. And I come over here. That's that point, which is at 0, comma, 0. There we go. So now let's do the same thing, but using a table instead of a graph. Now it's going to be the same exact steps, where we're going to do the inside first, and then we'll plug that answer we get for the inside into the outside function. So we're doing g of 5 first. That's the inside one. Now here on a table, here's how this works. I want g, so down the g column, of 5 across the 5 rows. So that's g of 5 gives me 3. So that is the answer to g of 5 is 3. G of 5 is 3. So now I plug 3 in for that whole inside part, and now I want to find f of 3. So I come down the f column, across the 3 column, and I get 0. So that is my final answer. So, having gone through one example of that one, I would like you to pause the video and try to do B and C. Let's see how you did. So for B, we wanted to find the inside f of 2 first. So down the f column, across the 2 row, and I get 8. So there's 8. And now I want to plug 8 into the outside function. So g of 8 down the g column across the 8 row is an answer of 0. And for C, I start with the inside f of 8. So down the f column across the 8 row gives me 5. There's my answer of 5. And then I plug 5 into the outside function. So that is f of 5. So down the f column across the 5 row for an answer of 9. We have one last problem that I'd like to do on this video, and then the last video will talk about one last subject, and then you're done. So this is example 12. Now we're going to do a story problem. The surface area S of a sphere is a function of its radius r, and is given by the formula. So here's our formula. S of r equals 4 pi r squared. Suppose the sphere is being inflated, so it's being blown up, so that the radius of the sphere is increasing according to the formula r of t equals 3t squared, where t is measured in seconds. So this is how fast the radius is growing. And r is measured in inches. We want to find S of r of t. That's what we want to find. So first, remember, S is the function that you start with the big parentheses. So I'm going to take the S function, and anywhere I see my variable r, I'm going to do big parentheses, 4 pi r squared. And then r of t is the equation I plug into those parentheses. So r of t is 3t squared. And now I'm going to simplify. So this is 4 pi 3t squared times itself, because it's being squared. So this is 4 pi times 3 is 9. T squared times t squared is t to the 4th. And then finally, 4 times 9 is 36. Whoa. Pi t to the 4th. So that is our equation for S of r of t. But we also want to interpret it. So we want to explain, what is this equation saying? What is it finding for us? So notice this equation plugs in time, and then it gets out surface area. So we plug t in and get an S answer out in the end. So what this is really finding, this equation is how fast the radius is growing. This equation is how fast the surface area is growing. And that's how we find S of R of t and interpret what this equation means. We only have one video left where we're going to take some functions and decompose them. That means take them apart.